Tutorial for NXTC basic configuration and wiring check. The block diagram is showing how the NXTC card was connected to a PLC without any actuators and only a sensor for measurement input. Local network settings. Before starting Sysmac Studio, the network settings of your laptop need to be defined. Type in network in the search field of Windows and select settings. Click on Change the adapter options. Double-click on your related network button and click to check properties. Choose Internet Protocol version 4 input as IP address, which is in the range of PLC, beginning with 192.168.250. Here 19 was inputted. The subnet mask is automatically assigned. Leave with OK. Confirm Ethernet properties also with OK and close Ethernet 4 status. Start your Sysmac Studio application. Project input and communication setup. Open a new project and name it accordingly. Input your project name. Choose your PLC. Select the used firmware version. Click on Create button. Move to the headline choosing Controller, Communication Setup. Select your used network. Here it is, Ethernet connection via a hub. Input the IP address of your PLC, which is 192.168.251 as default. Clicking the Network Test button to check right connections and settings. Click on the left yellow triangle button to go online. You might be asked to give a name to your new CPU, which could be done automatically from the program by clicking Yes. The yellow bar on top is showing that you are now online. Automatic registration of hardware. Select Configurations and Setup in the Multi-View Explorer. Double-click on CPU Expansion Rack. Double-click on CPU Rack. Right-click on the controller, choosing Compare and Merge with Actual Configuration. Click button Apply Actual Unit Configuration. Confirm with OK. Click on Synchronize to update the settings. Transfer to controller and confirm that no problems occurred. Now the synchronization process should be successfully finished. Push the Close button. Editing basic unit operation settings and carry out prior parameterization. Navigate to the tab with CPU expansion racks and click one time on your TC card. Here NXTC 2405 is used. Scroll down on the right side to push the button Edit Unit Operation Settings. In that window you will find a selection for all parameters on top. Please select channel 1. You can navigate either selecting your connected sensor or choosing on-off control if needed. But here you can also, for instance, set adaptive control parameters or add any offset to the processing values. With the Transfer to Unit button, the new values will be updated in the controller and you will be asked to carry on. In the next chapter, we'd like to register variables. Double-click on I/O map. Click on NX Bus Master. Click on your Install to C card. Here NXTC 2405 is used. Go offline with the yellow neighboring triangle button on the right side. The variable columns are activated, getting a white color. With your STRG key you can make a multiple selection of variables, just keeping it drop down. Keep the STR key pressed and navigate with your mouse cursor into the white variables table, where you make a right click to create device variables. Navigate to the programming folder on the left side and click once. Double-click on Data. Double-click on Global Variables to see successful registration. Now we get back to our CPU expansion rack field and like to push the button Edit I/O Allocation Settings. Click the button again. Select Input in the I/O mapping list. Click on Add I/O Entry. Choose Ambient Temperature on top and confirm with OK. Then press Apply and OK to finalize. Now the added variable is visible in the button of the blue value field. Go online again, pressing the left triangle button on top. Finally, we'd like to check wiring and want to carry out some simple commands. Again, we return to the I/O map selector focusing on the TC card. Click on the arrow of Channel Operating Status to extend the field. The same you do with Channel 1 Output and Alarm Status. And finally with Channel 1 Operation command. Scroll down to stop the controller, inputting True in the Channel 1 Run and Stop editor, confirming with the Return button. The true value field is turning red to confirm the change and activation. Furthermore, we like to set the auto-tuning Channel 1 100% AT function, also inputting True, which is also confirmed by a red color, but not yet active as the controller is stopped. The controller output LED are still turned off. Now we activate the controller, inputting false for Run Stop field. The control LED of the first output is activated and auto-tuning is started, which can be monitored in the value of AT activation parameter and heating control output changing to red color. Next, we'd like to increase the measured value for channel 1, pressing the thermocouple with our fingertips. We see how the measured temperature value is increasing, which is showing us the right wiring connections and correct configuration.